Hello, I'm Nick Scarth, and I'm going to be making homemade ice cream, and I'm going to make it with salted caramel. So, milk is an emulsion. I got milk mixed with a little bit of sugar and some vanilla extract. This is what we're going to be making the ice cream with as our base. So, like I said, milk is an emulsion. It's a oil and water emulsion. So milk has lipids and water as well as some protein and other sugars. One of the proteins in milk is uh, called casein, and that's one of the emulsifiers in milk. Now, what an emulsifier does is it breaks up the surface tension between the lipids and the water so that they can remain somewhat miscible in each other and just maintain that emulsion, stabilize it. Um, and some recipes for homemade ice cream, you'll find that they use eggs as part of their base. Um, the reason why they do that is eggs have lecithin, which is an emulsifier found in egg yolk. Lecithin has an HLB score. HLB stands for hydrophilic lipophilic balance, um, and it has a score of 4 to 9. Uh, Scores range from about 0 to 20, and a lower score corresponds to um, favoring an oil and water emulsion. Um, Another thing that milk has, um, and some other different emulsions may have, are large proteins that are called stabilizers. That they basically get in the way of the lipids combining and coalescing together. So uh, what I'm going to show you next is I have a pan here with a cup of sugar, and I'm going to caramelize it on the stove and make the salted caramel for it and add it to our ice cream base so we can freeze it and get our ice cream. So I'm going to turn this on to a medium. So table sugar is basically sucrose. Sucrose is made of glucose and fructose. What you're doing when you're adding heat is you're just breaking up the bonds. So you're splitting the sucrose into glucose and fructose. And those are then splitting up again and recombining to make different compounds. And that's what basically makes the caramel. That's what browns it, gives it its color and aroma. Sucrose is a non-reducing sugar, and glucose and fructose are. Um, Reducing sugars have an oxygen that donates electrons, um, and this is important because non-reducing sugars have a higher caramelization point than um, reducing sugars. So sucrose caramelizes at about 350 degrees. Glucose and fructose are about 300 and 220 degrees Fahrenheit. So there are other types of browning. There's the Maillard reaction and enzymatic browning. The Maillard reaction is um, proteins and sugars, combining and breaking apart and forming new compounds instead of just sugars. And then enzymatic browning is found in vegetables, fruits, and some shellfish, where the enzymes oxidize and produce uh, different molecules that cause the browning. So, like, if you, say, leave an apple out, um, when you cut it, after you cut it, the middle of the apple will start to brown because it's exposed to air. Um, how you prevent enzymatic browning is with stuff like adding an acid, so citrus. Um, you can blanch it, so just quickly and shortly expose it to heat. You basically just want to inactivate the enzyme. So that's browning. Um, right now our sugar isn't quite hot enough to melt, but this is an exothermic reaction, so once the bonds start breaking, they're just going to produce more heat and keep breaking. So this is a very hot reaction going on. So once it gets going, you just want to keep moving and stirring the sugar and caramel.